Hey, good afternoon, ladies and gentlemen. Our objective for today is that students will be able to create and use, so two things, an exponential equation to model a rabbit population. So we're going to be, again, looking at just more exponential relationships, and we're going to start to see growth factors that are just slightly different than some that we've seen before, right? So scenario for today says that in 1859, English settlers introduced a small number of rabbits to Australia. The rabbits had no natural predators in Australia, so they reproduced rapidly and ate grasses intended for sheep and cattle. Suppose that biologists had counted the rabbits in Australia in the years after English settlers introduced them. So this is actually based on a real life scenario. If you click on this link right here, that's a YouTube video that's going to just kind of explain what happened, why the rabbits started to just kind of grow so quickly, right? And just kind of why they're causing such a big problem. Now, part one, we're going to look at a table. So remember, we're saying, what if back then the settlers were starting to record what was going on with the rabbit population? So we have a table here, which is at time 0. We have 100 rabbits. Year 1, 180. Year 2, 325. Year 3, 583, etc. Right? Now, first thing that you're going to fill out here is what is the initial value. So how many rabbits did we start off with? That's given to us in the table. Second question, it says, what is the growth factor from year 0 to year 1? Now, if you're just looking at these numbers here, it might not look like it's actually exponential growth, right? We're used to seeing things that are doubling, tripling, maybe quadrupling, but this here isn't actually multiplying by an integer, right? It's definitely not multiplying by 2, otherwise this would be 200. But if I want to figure out what the growth factor is, right? That means that I'm just going to assume it's exponential. The way that you find the growth factor, pay close attention because you're going to do the same exact thing, is I'm going to look at comparing year 0 to year 1. So from year 0, we have 100 rabbits. At year 1, we have 180 rabbits. So the way that I figure this out is I divide year 1 by year 0. So I'm going to divide the one on the bottom by the one on the top. So I'm going to do 180 divided by 100, right? And that's going to tell me what the growth factor would be. So in this case, 180 divided by 100 gives me 1.8, right? You just put that into a calculator. And that again tells us that 100 multiplied by this number gives me 180. Okay, so that's how you find the growth factors. You're going to divide the one on the bottom by the one above it. So for the next one, again, you're doing the same thing over and over again. I say, what is the growth factor from year 1 to year 2? So now you're comparing year 1 and year 2. So you're going to do 325 divided by 180. And you're going to write down what you get, because that's from year 1 to year 2, right? Then you're going to do the same thing from year 2 to year 3, year 3 to year 4. The idea is that we want to see what's the growth factor from year to year. Do we always get the same number? If not, why not? What do you think might be going on here? Okay, so pause the video, work those out, then meet me on the next page. Okay, so top of the next page, it says, why do you think the growth factors you found weren't all exactly the same value, right? So they're all going to be slightly different, and just what do you think is going on in the situation that's making it so that they're not all exactly the same thing, right? I want to see what you guys think here. There's a lot of different logical answers. Now, last question in this section is, what value would you pick as the overall growth factor for the rabbits over the 4 years? So, like I said before, the numbers are not all the exact same number, but if you had to just pick one number and say overall from year to year, it's like I'm multiplying by this number, right? What number is that? Type that number in the box here, right? Now that we're done with that first section, what we're going to do is we're going to make our equation just like we did last week, just like you did yesterday, and then we're going to try to use that equation to answer some questions. So first thing it says is, assuming that the growth pattern continued, write an equation for the rabbit population. So it's giving me variables. Population P, that's one variable. For any year N, that's my second variable. N represents years. after the biologist first counted the rabbits. So just like we've been doing, you're gonna first figure out which of these two variables, P or N, is your dependent variable, write that here. Which one is your independent variable? Again, when you're figuring it out, you say which variable depends on the other variable. Now, your initial value, we identified that on the first page of the task, and the growth factor you wrote here. So whatever you wrote as your growth factor goes there, right? Then you put it all into your equation, right? So just remember where the different pieces go. Your dependent variable is gonna go here. Your independent variable is gonna go here. Your growth factor is gonna go in this box here. And your initial value is gonna go in this box here, right? That's gonna give us the standard form of an exponential equation, which again, remember, is y equals a times b to the power of x. So you might wanna pause the video at this point here just to help yourself build that equation. Remember, you're putting letters and numbers into these boxes, all right? Once you've got that done, the next thing that you're gonna do is you're gonna use your equation to answer a couple of questions. So we wanna figure out, based on that equation, what is the rabbit population gonna be after 5 years? What is the population gonna be after 10 years? And so on, right? So just helping you out with the first one here, right? It's telling us that the years is 5, right? So you're gonna end up substituting that 5 in for your independent variable and just computing. So it's gonna be whatever number you have here. I'm not gonna give it to you because I want you to write this equation yourself. So this number multiplied by this number raised to the 5th power, right? That's how you're gonna get that. Same thing for the next one. Instead of a 5, you're gonna write a 10. So whatever number you put in this box, multiplied by whatever number you have in this box, now raised to the 10th power, right? If you're not sure what to do with this part here, I will explain it during the Zoom session. Make sure you come and ask me, right? But I do not want to give you the equation right now because I want you to get in the habit of making it yourself. And I basically gave you a recipe here of how to do that, all right? So again, you can pause it here, add your equation in, and then if you're not sure, come to the Zoom session and I will help you out, right? So a couple more questions. After 15 years, 25 years, 50 years, same thing. Last question for this section is, looking at this number for 50 years, do you think that number sounds right? Do you think it makes sense, right? It might seem like a lot of rabbits, right? Do you think it's physically possible to have that many rabbits? And is there anything that our equation does not take into consideration that might affect how many rabbits are there, right? Just not thinking about math, thinking about the real world, what could be happening that the math here is not gonna actually tell us, right? Then the next part, if you're done with all that and still have some time, you're basically gonna go and do something that's similar to what you just did, except I gave you an equation here. The idea is to use that equation to identify what the growth factor is, what the initial population was, and then answer some questions that has to do with amounts of time that have passed, okay? Again, if you have any questions, feel free, please come to the Zoom session. I will help you out there, all right? If you don't come, I can't help you, all right? Well, good luck, and I will see you later.